Hello friends, welcome back to MLRITM. So today we are going to learn multiplication by using Vedic Mathematics method. Usually there are many methods in this, but here we will use one of the sutras, that is Urdhva Tiryabhyam, which is a vertically crisscross method. So before learning this method, let us see more how many methods are there to do this multiplication using Vedic Mathematics. So in Vedic Mathematics, we are having 5 sutras. As I have discussed in the introduction class, there are 16 sutras. In 16 sutras, 5 sutras contribute to the multiplication methods. Nikilam Navatas Karamam Dashataha. This is the base method which we have already learned in the subtraction. Then we have Anurupena subbase method. Then we have Ekadikena, one more than previous one. That is, we can solve one problem in various methods. Then we have the Urdhva Tiryabhyam, which is also known as vertically crisscross multiplication method. And then we have the Shunyat method, that is the reverse method. This method deals using zeros. Out of these 5 methods of application, we are using here Urdhva Tiryabhyam method, which is the most general and effective method to solve multiplications for larger numbers. Anyhow, today we will learn on product of any two natural numbers, which is the crowning gem of all the sutras. This sutra is more important than the other 5 sutras. So Urdhva Tiryabhyam is a vertically crisscross method to find product of two numbers. Here the number of steps required to get the product is one less than the total number of digits of both the numbers. To understand this descriptive PPT, we will go through one problem. See, for a multiplication of 2-digit numbers in the slide, assume we are having two numbers. First, we multiply vertically, then we crisscross, that is, we do left multiplication plus right multiplication, that is the steps 2, and then step 3 will be the right multiplication, which is already accomplished with provided left multiplication. If we go ahead with an example here, assume you have to calculate 53 into 47. To calculate 53 into 47, first you calculate 3 into 7. That is 3 into 7 will give you 21. So put this 21 aside. Then again you take the two numbers and vertically crisscross it. That is 5 into 7 plus 3 into 4 or 4 into 3, anything is okay. Then that will lead you to 35 plus 12, which is nothing but 47. Then you will do the left multiplication, left side of multiplication, that is 5 into 4, 20. Now these all numbers you will write together, that is 20 slash 47 slash 21. So this order is very important to get your answer. You will go with the reverse order, that is, first you will write the left multiplication, crisscross method, and then the right multiplication. So 20 slash 47 slash 21. In this we are having a 2-digit number for each slash. So whatever the unit digit is there, let it exist, and the other digit will be added to the next side of the number. That is, if you see here, in 21, 2 will be sent to the other side. So you will only remain with 1. Similarly, 4 will be sent to another side. So you will remain with 7. But 7 will be added to 2 because you have sent 2 before the number. So here 7 plus 2 will result 9. And here as well 4 will be given to 20. So you are getting 24. So therefore the answer will be 2491. In this, to have a review, we have 3 steps. The first step will start with the right side of the multiplication, then crisscross multiplication, then left side multiplication. After doing the 3 multiplications, you have to put the step 3 first, that is step 3 number will come first, then step 2 number, then you will have the step 1 number. In this, whatever extra digits you are getting, it should be added to the next side of the number, provided each number whatever you are adding, it should be added to the remaining ones digit of the number. Here in this case 2 is being added to 7, and for 20 we are adding 4. So 7 plus 2 is 9, and 20 plus 4 will give you 24, and so the resulting answer is 2491. Let us go to the another slide. See here another problem is there, that is 94 into 78. Repeating the same process again. First you will go through the right side multiplication, that is 4 8s is 32. Then the crisscross multiplication, that is 9 into 8 plus 7 into 4. So 72 plus 28 is giving you 100. And then the left side of the multiplication, that is 63. Now write all the numbers from step 3 to step 1, that is 63 slash 100 slash 32. Here the number of digits are more. So the method will be the same but little bit different. Here this 3 will be added to the 10. Why? Because here the unit digit is 0. So your answer will be 2, and when this 3 is being added to the 0, it will become 3, and here this 10 will be forwarded to the next side of the number 63, giving the answer 7332, which is the shown answer here. Let us go for the multiplication of 3 digits. These are some example problems which you have to solve using the Urdhva Tiryabhyam method. Whatever vertical crisscross method we have used now is known as Urdhva Tiryabhyam method. So try to solve these problems using Urdhva Tiryabhyam method. For multiplication of 3-digit numbers, the procedure is the same, but we have added 2 more steps because there are 3 digits. That is, we have to multiply a 3-digit number with a 3-digit number. Here we are considering natural numbers. This whole PPT is being displayed on the projection of only natural numbers. For other than natural numbers, there will be a little bit of deviation. So assume I have a 3-digit number. As usual, I will do the right side crisscross. The first crisscross is for the 2 rows of the number which are to the right. Then you will perform the crisscross for the whole, that is from left to right, then right to left, providing the mid of the number row. Then we will do the same crisscross for left of the number. Then you will end it with totally left. Let us go into an example here. Assume we are taking the multiplication of 212 into 543. So here my numbers are 212 is one number and 543 is another number. Both are 3-digit numbers and natural numbers. So first we will perform the multiplication from right. So 2 into 3 is giving me 6. So 6 will be written to the last because we write the steps from last to first, not from first to last. Next we will do the second step. So second step is we have to perform for the right rows crisscross. That is 1 into 3 is 3 plus 4 into 2. So resulting answer is 3 plus 8, 11. Then step 3 will be whole crisscross. That is first you will perform from left 2 into 3. Then you will perform from right, that is 2 into 5. Then the middle row as well, that is 1 into 4. So left plus right plus mid row. This step 3 is little bit hard to remember. We can make it using a little short method, that is left plus right plus mid row. So here we got 20, and now we will perform the same crisscross for the left side of row because our first crisscross was only with respect to right rows. So now we will perform with respect to left rows. So 2 into 4 plus 5 into 1. Then step 5, the last step, is on the totally left side of the sum. So here these all numbers will be written in a reverse order, that is 10 slash 13 slash 20 slash 11 slash 6. Since this number is single digit number, we have no issues, so it will remain the same. But here 11 we are having a 2-digit number, so you will place the units digit and let the tens digit to be added to the next side of the number, so 1 will be there. So when this 1 is being added to 2, the answer will be 3, and here you are having 0. So next, again here you will add this 2 to the 1, which will result in 3. Similarly, here 1 is there, which will be added to 10. So the answer you will get is 11,5166. That is 1,15,116. Little bit elaboratively, if we want to explain this, what we do is that 6, this 1 is the same, and here this 1 will be added to here. So when it is being added here, you are getting 0 plus 1 is 1. Then this 2 will be added to this 3. So 2 plus 3. Again here you are having 1. So this will move to the another side of the number. So here we are existing with 3. So 1, 5. Again you are having 13 here. So again it is 1, 1. And yes, this is the final answer. Thank you. In next PPT we will see another method for multiplication.